Hello, dear student. How are you? I hope you are all fine. I'm also fine. Thank you. Welcome to your channel, that is AZ Science Group. Today is lecture number 5 of Boron family of group 13. In today's lecture, we will be study about the comparison of boron and aluminum. Today's lecture will be about the comparison of boron and aluminum. But here in this topic, in comparison of boron and aluminum, here is two types of comparison. Here may be point of similarity present and point of dissimilarity present, sir. It may be points of similarities. Two different topics is present in this similarities as well as points of dissimilarities. But in today's lecture, I will be focused only on point of similarity. What is the similarity between boron and aluminum? I hope you will be ready. Okay, thank you. Let's start the topic. So we will be focused on points of similarities. The pen is not properly working. Let's change the pen. Similarities, sorry. So points of similarities between boron and aluminum. Points of similarities in between boron and aluminum. So in which points, for which points boron and aluminum are similar? Number first, in first electronic configuration. In electronic configuration, both have the same electronic configuration. That is NS2 and P6. Both have same electronic configuration. In the outermost shell, same number of electron is present. It means both have the same electronic configuration, means in the outermost shell same electronic cloud is present, sir. In the outermost shell same valency. This is the electronic configuration in both cases, in aluminum and in boron. That is, for boron, that is the electronic configuration is 2s2 and 2p1. 2s2 and 2p1. For aluminum, that is the electronic configuration is for the valence shell, that is 3s2 3p1. Means in valence shell electronic configuration same number of electrons are present. So here in third shell there is 3 electron, in second shell, that is valence shell in boron, here is also 3 electron present, while the valence shell of aluminum, that is third shell, that is M shell, where also 3 electron present, sir. This is the first similarity between electronic configuration. Next, valency. Both have trivalency. Both show trivalency. What is meant by trivalency? Trivalency means number of electrons in the valence shell that can be shared. Number of the electrons in the valence shell that can be shared. Here in the case of aluminum, here is 3 electrons present in valence shell that can be shared by the aluminum. So that's why their valency is 3. While in case of boron, that has also 3 valency, because 3 electron is present in the valence shell, so that's why that can be shared. So in both cases, both have the same oxidation state. both will be show same oxidation state. That's why for B it has plus 3 oxidation state. Plus 3 oxidation state also denoted the valency of the boron. Similarly, in aluminium, plus 3 oxidation state means oxidation state and uh, valency is same in both cases. Yeah, this is the valency. In both cases, valency is same. For next point, that is covalent character, that is covalency. Both cases, in both aluminium as well as boron, both show covalent character because both show covalent character. Covalency and valency it has almost same. Both show covalency means covalent character will be present in both cases as well as in boron compound is also in aluminium compounds. Why boron show covalency? Boron show covalency because it is difficult to get B3 plus ion, that is B3 plus 3 oxidation state. It is very difficult to get B3 plus ion because large amount of energy is required, and therefore because of high ionization energy, large amount of energy are required to ionize boron. So that's why, therefore, boron form trivalent compound. That's why boron will be form trivalent compound, that has 3 electrons will be shared by boron and form covalent compounds. So that's why it will form covalent compound, tricovalent compound, because these 3 electrons will be covalently shared. While in case of aluminium, aluminium has also formed covalent compound. It can however form electrocovalent compounds when it combines with strong electron accepting power. When only in case of when they combine with strong uh, electrocovalent compound. Electrocovalent compound. It will be combined strong electron accepting atoms or groups. It can form electrocovalent compounds when it combined with strong electron accepting compounds. So that's why in this case, only in this case, aluminium will be undergo oxidation plus 3 oxidation state. But here it will ionize, it will lose 3 electrons. But here except this case, aluminium show covalency. Aluminium will be shared 3 electrons of their valence shell by covalently because of aluminium is small size. Due to very small size, it have high charge. On small size, it have high charge because aluminium plus 3 have very small size, and on small size and high charge it have high polarizing power. So that's why this account for covalent character even in case of electrocovalent compounds. For example, in case of AlCl3, AlBr3 and so on, AlH, AlI3 all have covalent in nature. These about covalency. Let's go to the next point, that is oxidation state. That is oxidation state. I'm really sorry, I just forgot that where is the camera. Okay, sorry, these are about the previous points. Okay, thank you. Oxidation state, both show common oxidation state, that is plus 3. Both show common oxidation state. That has plus 3 in majority. Plus 3 in majority. that is plus 3 in majority compounds. And this is the same oxidation state for both in case of aluminum as well as for boron. Like I am writing some example, that is in case of for boron, that is B2O3. In case of boron, that is oxy acids. Here is boron has also plus 3 oxidation state. In case of BCl3 has also oxidation state, while similarly in case of Al2O3, aluminum has also 3 plus 3 oxidation state. In case of AlCl3, aluminum has plus 3 oxidation state. In case of BCl3, boron has plus 3 oxidation state. In case of H3BO3, boric acid, oxidation state of boron is plus 3. In case of AlOH3, aluminum hydroxide, in case of aluminum hydroxide, it has also aluminum has also plus 3 oxidation state. In case of NaB4O7, oxidation state of boron is plus 3. In case of similarly in case of NaAlO2, oxidation state of aluminum is plus 3. I hope this point will be clear. Boron, however, also show oxidation state of minus 3 in case of metal borides. The pen is not properly working. Now I am changing the pen, sorry. However, boron show in oxidation state of minus 3, in oxidation state of minus 3, but only in case of metal boride. In case of metal boride, only in case of metal borides. That is Mg3B2, that is magnesium boride, are also called metal boride because magnesium is metal, so that's why that is called magnesium boride, metal boride. Oxidation state of boron, here in this case oxidation state of boron is minus 3. So why, here is one question arise, that why boron can have negative oxidation state, that is minus 3. If you have answer, please comment me. And this is your assignment for the current lecture, that why boron can have negative oxidation state. I want answer from you. I will be answered you later in next lecture if you doesn't provide me answer. Okay, go to the next point, sir. Next similar point, sir, that is action of alkalis. Action of alkalis. For 5, action of alkalis. What is alkali? Alkali, the first group is called alkalis, that contain the hydrogen, not hydrogen because hydrogen from hydrides. That is called lithium, beryllium, metal of first groups. Lithium, sodium, potassium, these are alkalis. So alkalis both dissolve in alkalis, both are dissolved in alkali, both are dissolved in alkali. And evolve hydrogen, that is the similarity between these two things. And evolve hydrogen, that is, for example, in case of boron, when you add 2 boron plus 6 NaOH, it generates 2 Na2BO3 plus 3 H2. H2 will be liberated, H2 will be evolved. This is for boron. While for aluminum, when 2Al combine with 2 NaOH, it generate in the presence of aqueous solution. It generate when sodium hydroxide dissolve in aqueous solution, present in aqueous solution. When we add to this aqueous solution that aluminum, so it generate 2 NaAlO2, that is also called sodium meta-aluminate, while that is called sodium borate, Na2BO3, that is Na2BO3, that is called sodium sodium borate, while NaAlO3, NaAlO3, that is called sodium meta-aluminate. Sodium meta-aluminate, aluminate plus 3H2 liberated. H2H is evolved. This is in both cases, both are dissolved in alkalis and evolve hydrogen in both cases. This is similarities. Okay, now I am cleaning the board to proceed the topic. You can take screenshot or you can rewind the video. Okay, thank you. So the next point is, in both cases for action of concentrated, in both cases action for concentrated, action of concentrated H2SO4, of concentrated H2SO4, what will be happen in both cases, in aluminum as well as in boron? Both react with concentrated H2SO4 and evolve sulfur dioxide. Both are reactive. Let's see here. For example, H2SO4 in aqueous solution, H2SO4, it can be generated into H2O plus SO2. In both cases, SO2 sulfur dioxide will be evolved. Sulfur dioxide will be evolved plus oxygen. So, for when we dissolve 3 sulfuric acid, it will be generate 3. So here for 2 boron plus when 3 oxygen mix with, when 3 oxygen is 3 oxygen, so it will be lead into boric anhydride. This is boric anhydride. Yeah, but in case of aluminium, what will be happened? After that boric acid can be that boric anhydride can be attack on H2O. B2O3 can be attack on or you can say that water can be attack on this boric acid. On this, sorry, this is not boric acid, this is boric anhydride. After that, after this attack, it will be generate boric anhydride, boric acid, H2 H3BO4, H3BO3. This is boric acid. Similarly, for sulfur, for aluminium, when 6H2SO4 react with, similarly for this step, like in the above case, similarly, it will be generated into Al2SO4, SO4 3 plus 3SO2 plus 6H2O. In both cases, sulfur dioxide are evolved and both are reactive toward concentrated H2SO4. This is the similarity between. And let's proceed to the next point, that is formation of oxides. In both cases, both form oxides of the type M2O3. Both form oxides. Both form oxides like M2O3, like this is, that is B2O3. Similarly, for a case of both are reactive when both form oxide like M2O3 when heated in atmosphere of oxygen at high temperature. For example, for boron, when they are when they are heated in atmospheric oxygen, means heated up to 700 degrees centigrade, it will be generate 2B2O3, that is boric anhydrides or boric oxides. Similarly, for aluminium 4Al, it will be similarly attacked but 800 degree centigrade temperature, it will be produced Al2O3, that is aluminum oxide or alumina. It is also called alumina or aluminum oxides. The oxides are amphoteric in nature. These oxides are amphoteric in nature. These are amphoteric in nature. Also, formation of chlorides. In case of formation of chlorides, both form trichlorides. Both form trichlorides. Both form trichloride either by passing chlorine heated over heated boron or alumina. For example, in case of 2B, when they are added with oxygen chlorine gas in the presence of high temperature, when they are heated, it generate 2BCl3. Similarly, that is boron chloride. While similarly for aluminium, same case, when they are heated, it generate 2AlCl3. Both form trichlorides. Both have similar behavior. Similarly, in case of formation of nitrides, formation of nitrides, both form nitrides of the type amine. Both form the nitrides of type amine when heated with atmospheric nitrogen or ammonia. Like in case of when 2B are heated with N2, it generate when two boron atom are heated with N2 molecule, one N2 molecule, it generate 2BN, that is amine. M means that is for either M used for boron or aluminium. So here BN generator. Similarly, when they are heated with ammonia NH3, it will liberate hydrogen gas plus H2. When there is 2NH2, here will be 3H2 will be evolved. Yeah. Similarly, for aluminium, 2 aluminium for N2, it will be generate 2AlN. Also for ammonia, it will be generate 2AlN, same thing, plus 3H2, hydrogen will be liberated. Hydrogen will be evolved. This for nitrides. These are similar points between boron and aluminium. Let's proceed the topic. I am clearing the board. You can take screenshot or you can rewind the video. So for next point, that is formation of sulphides. Sulphides. In both cases, both form sulphides. That is type M2S2, like M2S2. Both form sulphides. Both form sulphides like M2S2, M2S3. When they are heated with sulfur, like in case of when boron are heated with sulfur, it produce B2. When they are heated, it produce B2S3. Similarly, when aluminium are heated with sulfur, it produce, when heated or sulfur, it produce Al2S3. they produce sulphides. These sulphides can also be hydrolyzed, like that is B2S3 that can be hydrolyzed say by water and produce boric acid H3BO3 plus 3H2S. Similarly, for Al2S3 plus 6H2O, similarly it will be generate 2AlOH3 plus 3H2S that can be hydrolyzed. So similarly for next point, in these both cases formation of sulfides, boron and aluminum both form the sulfides. Also both form the formation of alkyl compound. Both can be used in the formation of alkyl compounds. Alkyl compounds. Like for example, both form similar types of alkyl compounds. Both form similar types of alkyl compounds like such as BC3 or AlC3. For example, when 2BCl3 plus 3ZnCH3 they are reacted, it produce 2BCH3 that is alkyl compound plus 3ZnCl2. For boron, then for aluminum similarly, when 2Al are reacted with ammonium alkyl ammonium, that is AgCH3 into 2, that is it will be generated into 2AlCH3 similarly plus 3Ag will be generated. This is for in both cases these are same, both are reactive towards alkyl and generate alkyl compounds. Similarly, both have reducing nature. Why both have reducing nature? That is very important point. Both have reducing nature because both are electron deficient compound. Both can add electrons. Both can gain electrons and reducing. Both can gain electrons, so that's why they are reducing Ag. Not sorry, both can yes, both can add electrons. Reducing agent. What is the definition of reducing agents? What are the definition of reduction? Reduction definition means the loss of oxygen, gain of electron, or gain of hydrogen or hydride. So in both cases gain of hydride. Reducing nature means the boron and aluminum are reducing nature because it have the deficiency electron, it have one vacant orbital, so that's why it can add electron, it can gain electron, it can gain hydrides, it can also loss of oxygen, but here in both cases oxygen is absent, so oxygen is not present, so that according to these two definition, that can gain electron, that can gain hydrides, so that's why the another compounds like in case of aluminum, when they are heated with CrO3, let's suppose they are heated with 2Al are heated with CrO3, means they will be reduced this compound, that is chromium oxide, that they will be aluminum will be reduced chromium oxide. How they will be reduced? They will be the chromium will be lost oxygen. When they lost oxygen, it will mean the chromium oxide will be reduced. It is due to aluminum reduce this chromium oxide, so it will generate product Al2O3 plus 2Cr. So let's see here, oxides, that is three oxides or three oxygen molecule atoms are gained by aluminum or you can say that 3 oxygen atoms are lost by chromium oxide, so that's why chromium oxides are reduced here while aluminum are oxidized here. Boron and aluminum are itself oxidizing, isn't it? Or you can say that boron family by itself it are oxidizing. Boron family are oxidation in nature. Sorry. I hope my point will be clear. So similarly for boron where 4 boron are react with the 3 carbon dioxide, it will reduce carbon dioxide and produce 2b2o3 plus 3 carbon will be generated. This is for boron. So that's why they are reducing nature. Similarly for next point, that is 12 points I am writing here. That is acid of steam, action of steam, action of steam. In both cases, both reacts, both that is boron and aluminum, both can react with steam at red heat liberating hydrogen. Red heat liberating hydrogen means that at very high heat, when they are heat, when water are very high heated, it can convert into steam. So at that point, both aluminum as well as water can be react boron with boron and aluminum and produce boric anhydride, and also hydrogen will be evolved. So for aluminum will be decomposed boiling water. Aluminum can be decomposed boiling water. Yeah, here it will be attack water. It can be react with the aluminum, can react with water and produce aluminum hydroxide plus hydrogen gas will be evolved to the atmosphere. Okay, these all are the about symmetries. These all are symmetries of boron and between aluminum and boron's. Symmetry between aluminum and boron. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal or Gmail that I put in description box. If you have any, I hope that will be cleared. Okay, thank you very much. Also please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my dear student. Very best of luck. Goodbye.